Let's try to solve this JEE Advanced 2025 question. Let's start by collecting the information that has been given to us. The center of the disk of radius r and mass m is attached to a spring of spring constant k inside a ring of radius capital R greater than small r. The other end of the spring is attached to the periphery of the ring here, and both the ring and disk are in the same vertical plane. That means we have gravity acting downwards. The disk can only roll along the inside of the periphery of the ring without slipping. This is important. The spring can only be stretched or compressed along the periphery of the ring following the Hooke's law. In equilibrium, the disk is at the bottom of the ring, assuming small displacement of the disk. This is important. The time period of oscillation of center of mass of disk is written as t equals 2 pi by omega. We must find the value of omega. So let's start by writing the forces that will act on the disk when it is displaced. Let me draw a displaced instant of the disk. For visual representation, I'm taking the displacement as big, but we must keep in mind that this theta by which it is displaced is small. Let's start by writing the force due to the extended spring on the disk, which will be equal to k into r minus r into theta. Now here we take r minus r, since the distance from the center of the ring to the center of the disk is equal to r minus r, and the spring will be displaced something like that. So now let's write the torque due to spring acting on the disk about its instantaneous point of rotation, which will be equal to k into r minus r into theta into small r. Now gravity will also be acting on the disk, so the force due to gravity is equal to mg into sine theta, just like what would happen on an inclined plane. But here, since theta is very small, we can approximately write sine theta as theta. And so the torque due to gravity will be equal to mg theta into small r. Now, through formulas of rotation, we know that the total torque acting on the disk will be equal to the moment of inertia of the disk about its instantaneous point of rotation into the angular acceleration of the disk about its instantaneous point of rotation. So this is an important formula. Let me label it quickly. Now we can replace the torque total as torque spring plus torque gravity. So we can write k into r minus r into theta into small r plus mg theta into r is equal to I alpha. So now we can write the moment of inertia I of the disk about its instantaneous point of rotation. Now about its instantaneous point of rotation, the moment of inertia will be not half mr square, but it will be 3 by 2 mr square, since the moment of inertia of a disk about an axis passing through its center is half mr square. But the instantaneous point of rotation is here, and the axis is something like this. So here we are using parallel axis theorem to shift the axis by a distance of r. So an additional mr square is added to the moment of inertia, resulting in a moment of inertia of 3 by 2 mr square. So here we can replace I as 3 by 2 m r square. Cancelling r's from both sides and taking 2 by 3 by 2 m or to the other side, we can write alpha is equal to 2 by 3 into k into r minus r by mr plus g by r into theta. Now we can replace the angular acceleration of disk about its instantaneous point of rotation with the linear acceleration of the disk divided by radius, small r. We can cancel small r from the denominator of both sides, and now we can finally replace the linear acceleration using formulas of SHM. We can write linear acceleration is equal to linear amplitude into omega square. Here the linear amplitude is r minus r into theta, so we can write A is equal to r minus r into theta into omega square, since we are calculating for SHM about this point. So now replacing this, we can write r minus r into theta into omega square is equal to 2 by 3 into k into r minus r by m plus g into theta. Now cancelling theta from both sides and bringing r minus r to the denominator, the final calculation gives us the value of omega as root of 2 by 3 into k by m plus g by r minus r. So the final answer is A.